Here we are trying to show why the k-means algorithm is kind of gradient descent when the objective is the total distortion. So first, let's write down the objective. So we're trying to minimize, by choosing the cluster centers, the total distortion, which is the sum over all clusters, say it's k to k, and sum over all the data points within the cluster k, and then the distortion is the distance to the center. So the center is small letter c, k, and then you should have the norm and the two norm. In particular, two norm work, other norms will not work. So I'm using two norm here, and we want to try to minimize this, and we want to show that the gradient descent step is the k-means algorithm. So the first thing to do is we want to differentiate this with respect to one cluster, say ck. But let's actually use another variable so that's not confusing. So let's say differentiate with respect to cr. So this is cluster center r. Then when you differentiate, because it's a sum over all different clusters, when you differentiate with respect to cr, it means all the other ones are not relevant. Because when you differentiate with respect to those will become 0. So this sum automatically disappears, but you do have this left. And let's write down this with some vector multiplication, which is just this transposed times this, and set it equal to 0. So when it is 0, it should be the minimum. And then what to do next? Yes, differentiate this thing. So use the product rule. Derivative of the first one, which is -1, multiplied by the second one, plus derivative of the second one, which is symmetric, multiplied by the first one. Note that the sum is still here, and it should still be 0. So let's organize this. This is just move the 2 outside and -2 outside, and x cr. This is just x minus cr is equal to 0. So the 2 and the 0 divided by 2 is still 0. And maybe let's write it so that we put this thing outside the sum. Right now this is inside the sum. So put it outside the sum, you get x minus the sum of this constant, basically like this. So how many are there? It's using the notation, it's just absolute value, or the number of elements in this cluster CR. So this is basically combining them. It's absolute value CR, this is capital, this is the cluster, and multiplied by small cr, this is the center, and it's equal to 0. So last step, rearrange this. You get cr is equal to 1 over absolute value of cr, the cluster size, and sum over the x. So that's the centering step in k-means.